Hello, welcome back everyone. We're on question 33 out of 35, almost done with this AP Physics C Mechanics multiple choice test. This problem, it's the first one in a set of three, so I'll read the scenario and then the problem, then we'll dive in. An object is initially hanging in equilibrium from a vertical spring. The object is pulled down 15 centimeters from its equilibrium position and released at time t equals 0 seconds. The object then oscillates with the period of 2 seconds. And question 33 asks us, what is the position of the object at t equals 3 seconds? The options it gives us are A, 15 centimeters, B, 7.5 centimeters, C, 0 centimeters, and D, negative 7.5, and finally E, negative 15 centimeters. So let's talk about the themes at play here in this question. So first, we're going to identify this as simple harmonic motion. We know that because this object hanging from the spring is going to be oscillating. That word gives it away a little bit. This tells us it's simple harmonic motion, and the fact that there's a spring here. Simple harmonic motion basically means we're going to be using trigonometric functions here. So the first thing we should do to solve for the position is we should write a trigonometric equation for the oscillation of this spring. And we have all the information right here. We don't have to do any additional equations to get it. We can write our trigonometric equation as is. So I'm going to write this as P as a function of t. The P is going to represent position, so position as a function of time. And the first number, the coefficient of either sine or cosine, is going to be our amplitude. So it's going to be how far from the equilibrium position this object is moving in either direction. So what does it tell us? It says it's hanging in equilibrium. It's pulled down 15 centimeters. So it's going to, if the equilibrium position is here, it's going to start here. It's going to go up 15, back to equilibrium, down 15, up 15. So our amplitude is 15. However, when we write this, we have to be aware that its starting position when t is 0 is at negative 15. We see here that it's pulled down 15 and the positive direction is defined as upwards. So that means we got to slip in this negative sign to indicate that it starts in the negative direction, it's pulled down, and as it's released, it moves upwards in the positive direction and comes down. So the next part of the equation, since it's not starting at equilibrium, but it's starting at its full displacement from equilibrium, it's going to be a lot easier to represent this in terms of cosine. We can also write it in terms of sine, but that's more challenging. There's no point in doing that. This equation isn't for them. It's for us to figure out how to better represent this. So the next thing we're looking at is the period. We want to figure out what our coefficient of t in here is going to be. So to figure this out, our coefficient of t times the period is going to be equal to 2 pi. So a simpler way of writing this is 2 pi over the period is equal to this number. I'll call it z for now. Yeah, whatever. I'll call it z. So 2 pi, what is our period? 2 seconds. So 2 pi divided by 2. 2's cancel out, it's going to be pi. So we have our equation. And let's think about what the period means in this case. So that means it's going to take, from the time it's pulled down, if an entire period takes 2 seconds, it's going to go up, hit equilibrium, reach the top of its rotation in the positive 15 direction at 1 second. And then it's going to come down to negative 15 again, complete that full cycle at 2 seconds. So this is asking what is the position of the object at t equals 3 seconds. So we can just think about this knowing what we know about the period, that at 3 seconds it's going to be it's going to go 1, 2, 3. So based on that, it's likely going to be positive 15. I'll put a little plus sign here because we think it's going to be positive 15, but we can go ahead and solve it. So t is 3. I'm going to rewrite this. It's going to be a little bit tiny. I can zoom in later. So p of t is equal to negative 15 cosine 3 pi. That's hard to read. My handwriting doesn't help either. So 3 pi, we can just subtract 2 pi because that's a full circle. So cosine of pi, think about the unit circle. Think all the way back to last year in math class. Cosine of pi is going to be negative 1. So we have negative 15 times negative 1, which gives us positive 15. So the math checks out with our cognitive representation of the problem if we visualize it. Yes, the correct answer here is going to be 15 centimeters after 3 seconds. It's going to be in the positive displacement. That wraps up the video. Let me know if you have any questions about simple harmonic motion, about writing this trig function, solving for it. Thanks for watching, and make sure to check back in for our last 2 videos. We're almost there, guys. Thanks.